2. So we're working on completing the square in vertex form. That's our major goal. I just got done talking to you about trying to complete the square. So here is an image on the board. I want you to concentrate on this image. I'll highlight so the folks watching this can see. This image here, what does it appear to be?
Some sort of...
Some people might say it looks like the image is a square. Do you agree that we could probably call it a square?
Yeah.
What is the area of this overall shape? Now, remember what our key was. Every time we see one of these red squares, it's going to have an area of what? That's an x squared. Every time we see one of these blue rectangles, it's going to have an area of what? X. And every time we see one of these, I don't have a yellow marker, so we'll go with black. This yellow is going to have an area of 1. So what is the area of that overall square that's pinned in by this?
1x cubed with 4. Number 4. So I'm looking for.
Well, I'm hearing 1x cubed, and I'm a little bit perplexed on that.
X squared plus 2x plus 1.
Yeah. What's the area of this one here yet?
X.
That's an x. So what's the overall area? X squared plus 2x plus 1. Does that represent the area of the overall square that I gave you from the very beginning? I'm hoping that you're going to say yes, you agree with that. Now I also want to concentrate on the dimensions. What are the dimensions of this square? You guys wrestle with it. I got to do something here quick. My screen is off the record.
So the kids that are watching this right now
Or seeing blue screen, I think.
It's still recording?
It should still be recording, yeah. These just got hidden back here, and I can't have them stay hidden.
So they're probably laugh.
Good for them. I hope they get a little chuckle.
I know that's squared and
Okay. I asked you about dimensions. What are the dimensions of that? Well, this thing here. What is this dimension here?
that would be x plus 1.
It is an x plus 1. What is this dimension here?
Same thing.
Because it's a square, it better be the same thing. Do you see how it's both an x plus 1, x plus 1?
Yeah.
So the dimensions are x plus 1 times another x plus 1, but in a more compact way, we could write that as
X plus 1 squared.
x plus 1 squared. This represents the area of a square.
Yes.
Now I want to link in your mind, whenever you hear the word completing the square, I want you to think about creating a square, like I have here. Completing a complete square. Alright, so this is going to be tricky. How can I do this? Okay, that works. I'm going to show you another square, hopefully. We're going to bring this one over here. And I'm going to bring one of these over here. Do I have a complete square so far? No, I would need to do a few more things to complete this. Come on, little doggies. One here. Here. Oh, why are you being difficult?
Doesn't like you?
Well, neither do you, but I still put up with you.
Well, maybe someone in County Party.
Maybe someone wouldn't stew over the past would be okay. Let's keep going. What is the area of this square that I've created?
X squared plus 4
Squared plus 4x.
Plus 4x plus 4. What are the dimensions of this square? So I'm asking you, what is this dimension by that dimension? So that would be for the area, an x plus 2 squared. Perfect. Well, for the sake of having way too much fun, maybe I'll grab another one of these with another one of these, and then I need to complete the square. I got to fill it in with some other stuff, so these are being sticky.
Good change.
That one?
Put them different color.
You don't like yellow?
I'll make it just a different one. Something new.
Yeah, you should put in one of those.
No, nothing new, please.
No, I kind of like things that are from the past, you know, because you can learn from things from the past, so you don't repeat them.
Yeah.
Okay. Okay, guys, how about we just...
What is the area of this newly created square?
X squared plus 6x.
Still with the hand.
X plus 9.
Hey, Austin, yeah.
So we have an x squared
Uh,
plus 9. So our area is calculated by taking the dimensions of. Now part of what I want to illustrate is a common mistake that people make when they take two binomials and square. So what if I had a binomial that was x plus 4 squared? What does this x plus 4 squared represent?
that's one side, one side.
And then what does it represent? What idea have I been doing here? What does it represent? Area. This should represent the area of a square. How do I know it's a square?
Because it has something.
Because the two dimensions are exactly the same. So this is going to represent the area of a square every time. What is the area of a square that has a side length? Now I didn't put it on here, but if I add another one of these and add another one of those, then I have to add some more of these buggers. So just quickly fill those in. What should the area end up being?
X squared plus 10x plus 25.
X squared plus 8x plus 16. And that would have been my next one. It's x squared plus 8x plus 16. And I want to go back to the point I started to make. We have a lot of people that have a lot of difficulty taking these numbers and multiplying. You know what I get for a common answer? What do you think I get most of the time when I give someone an x plus 4 and I say, square that? X squared plus 16 is what I normally get people to do. Now, is that accurate?
No.
What I'm trying to do is portray a mental picture in your head. Whenever you take a binomial and square it, you must get a trinomial. Look at these. This is a binomial. We squared it. Your answer was a trinomial. Square a binomial, you have to get a. So I got a little phrase that runs through my head. Whenever I square a binomial, I get a trinomial. Square a bi, I get a tri. Square a binomial, you always get a trinomial. Now, we want to be fast. Another way of saying fast, we want to be efficient. But we also want to be accurate. I don't want you to see you make that mistake. So whenever you square a binomial, it's basically FOIL. But when I do this, I'm going to square the first thing, which is x squared. I'm going to square the last thing, which is plus 16, but I know it's going to create a trinomial. What's this middle always going to be? And there's a simple way of calculating this. Take these two and multiply them together. That's 4 times x, and then you double it. 8x. Let's try this one. X plus 5 squared. Square the first thing, which is x squared. Square the last thing, which is 25. Now you double this, plus 10x. We want to have some speed and efficiency here because we're going to be doing a lot of these calculations. We don't want to be bogged down in FOIL and having to do that monotonous thing over and over again. So this is a speedy procedure of squaring a binomial. Mr. Williams, when you square a binomial, you'll always get a? When we square a binomial, we always get a? Trinomial. Mr. Williams, what we always get when we square a binomial, we will get? Trinomial. When you square a binomial, you get a trinomial. What does this trinomial represent? What do every one of these trinomials represent? Area of a square. Remember the whole thing I was telling you about when you came in and we started doing this? I said we're going to focus on the area of squares. These things are called areas of squares, perfect squares. All right, I want you to create the area of a perfect square, and then we'll figure out what its dimensions were. See if you can create the area. Give me a representation like these, the area of a perfect square. Be helpful if you help us out here, Coach. Come on. Find the area of a perfect square. Give me a trinomial that represents the area of a perfect square. And we're going to put you to the test. You're going to give us your trinomial. We'll see if it really represents the area of a perfect square. And if it is, what dimensions is it? Chris, you got one?
Yep. X squared plus 24x plus 144.
You believe that's the area of a perfect square. So it would have to be a square that has what dimensions on it? Someone else said didn't create that. What is it? Can't just be 12 by 12 because that'd just be a 44. So add to that. Wow, look at all the examples we have on the board of things that work like this. We just didn't put 12, we just didn't put 4, we just didn't put 3. How about an x plus 12 times another x plus 12? If you take an x plus 12 squared, do you get what Chris gave us originally? If we square the first thing, what is the x squared? X squared. You square the last thing, 12 squared is 144. What if you doubled the two x and 12? 24x. So did Chris create a perfect square? That represents the area of a perfect square. Now loosen some traction here with you folks. Are you getting what we're trying to get you to think about? I need you to think about trinomials that represent the areas of perfect squares. And if you can do that, you can tell me what the factors are. Anybody else think they create a area of a perfect square? Not everybody all at once. Okay, Cody, go ahead.
X squared plus 10x plus 100.
Let's put it to the test. What do you think the dimensions of your square are if you said that's the area of it? What did you think?
Just X plus, yeah, X plus 10.
You think it's an x plus 10 times an x plus 10?
Yeah.
Okay, so that means if we took an x plus 10 and we squared it, it would give us this answer then.
Yes.
Okay, so you square the first, x squared. You square the last, 100. It would have to be 20x. Okay, so here's where I'm going to put a little plug in for my little phrase here. Whenever we multiply these things, the x plus 10 times another x plus 10, when you square the first, you're just taking first times first, x times x. You square the last, you're taking 10 times 10, that's 100. On your outside, inside, outermost, innermost, if you have the same numbers here every time, that's a 10x and that's a 10x, how many do you really get? So here's what I do in my head. When I got to square these, I square the first, square the last, double the OI. Where is the term OI coming from? Your outside and your inside of your binomials. Double this OI. So Cody was close but didn't quite get there. 20x. Okay, let's try another one. Clear the whole screen here. Go ahead.
X squared plus 18x plus 81.
Is that a perfect square area of a perfect square? If so, what are the dimensions? X plus 9 squared. So I'm trying to get you to think about perfect squares and how to find areas when they're not just numbers. So you getting some traction here? Okay, now the whole purpose of this is to get it into another form called vertex form. Now we're going to divert from this for a little bit. And I want you to look at some graphs that I have created here on Desmos. Here is the equation of the graph I want you to pay special attention to. And in particular, I really want you to focus on this red dot down here that's highlighted. What would you call that in that parabola? It's a 0. That's a good. It's an absolute minimum. This absolute minimum is called the vertex. Now, the form that we're going to put it in is called vertex form. So evidently, the form that we put it in is going to help us find the location of the vertex. First observation I want you to make is, what does this value of A do? Now notice where A is. A is out in front here. Okay, so what is A going to do to this graph if I move it around? As it gets bigger, it squeezes it. It's a vertical stretch. And as it gets, oh, why did it go down there? Explain to me why it's down below. because it's negative. Anytime A is negative, it's going to be frowning. Anytime A is positive, it'll be smiling. The bigger the number, the steeper it is, the more vertically stretched it is. What happened when A was a 0, by the way? Did you see that? It's a constant. So we no longer have a quadratic anymore. It's just a constant. So let's leave this here at 1 for a little bit. I want you to see what H does. See where H is in your equation? Play that. What does that H have to do with the location of the vertex?
Is it on the X?
Okay, it's moving along the x-axis, and the x-axis is what kind of a movement? Horizontal. They got an H there. It helps you locate the horizontal movement. Okay, so what else can we do to this point? Now look at K. What's K going to do to it? Now it's moving it which direction? Vertical. They don't use V. I don't know why they didn't use V. They always use K. K is a constant that moves it up and down. So can you figure out by the equation that I'm showing you where the vertex is going to be? If I stop this and freeze frame it, does it make sense that the vertex is at -2, 2? Look at your value of H, look at your value of K. Now you got to be a little bit careful. You put in H as a -2 and it's going to be X minus a -2, so it's really going to read X plus 2, hope it writes, or not. It will really read X plus 2 squared, plus K. And that's going to be plus your 2. So here's what I want you to be able to do. We'll get rid of that. We'll insert a new. Where do you think the vertex is going to be if I gave you X minus 4 squared plus 3?
Positive 4.
4, 3. Is this graph smiling or frowning? Smiling, because this is, so is this point an absolute maximum or an absolute minimum? That's going to be an absolute minimum. So I'm going to feed you another one. What if you had y equals a negative x plus 2 squared minus 7?
Would be a -2,
The vertex will be at -2, -7, and it's going to be what kind of a curve? Frowning curve. So this -2, -7 will be a, remember on your quiz, you had to figure out the ticket price that would give you the maximum profit? That's what we find quite often. Absolute maximums, absolute minimums. We want to maximize our profit. We want to minimize our costs. We want to minimize our surface areas. We want to maximize our incomes. Yes?
So when it's a negative right above there, it only really goes towards the parentheses.
The only thing this does, tells you the direction of its opening. This is just like your zeros were before.
Okay.
So we're going to try to keep times together on Monday, this whole idea of completing the square and vertex form. By the way, do you see the completing the square in this form? Do you see the area of a square representation?
Yeah.
It's sitting right here, isn't it? That represents the area of a square, and that's what we're going to be creating. All right, have a good weekend. Cheers up.
Good night. Good night.